You are looking at something right now, and that may already be changing it. Not in a poetic sense, not as a metaphor, but in a way that has forced physicists to rewrite the rules of reality. In some of the most controlled experiments ever performed, the simple act of observation alters the behavior of matter itself. What was once possibility becomes fact only when it is observed. This raises a disturbing question most people never stop to ask. How can looking be so powerful? If observation can influence particles, time, and even outcomes, what does that say about your role in the universe? Are you really just watching reality unfold, or are you involved in ways science is only beginning to admit? At the smallest measurable scale of reality, something deeply unsettling happens, not metaphorically, not philosophically, literally. The moment a scientist tries to observe a quantum particle, the particle behaves differently than it did before being observed. This is not speculation. It is one of the most rigorously tested phenomena in modern physics, and it sits at the center of what is known as the observer effect. In everyday life, observation seems passive. You look at a tree, and the tree does not change because of your gaze. You watch a clock, and time continues to move forward regardless of your attention. Classical physics was built on this assumption that the universe exists independently of who is watching it. The observer is separate from the observed, clean, safe, predictable. Quantum physics shattered that comfort. When scientists began studying particles like electrons and photons, they discovered that these particles do not behave like solid objects with fixed properties. Instead, they exist in a range of probabilities. An electron is not in one precise location until it is measured. Before observation, it exists as a cloud of potential positions. The act of measuring forces that cloud to collapse into a single outcome. This is where the paradox begins. To observe a particle, scientists must interact with it. They must shine light on it, place a detector near it, or otherwise disturb it in some way. And the moment they do, the particle's behavior changes. It is not simply revealed, it is altered. Reality at this level does not appear to be a finished product waiting to be discovered. It behaves more like a draft that becomes final only when someone looks. One of the most famous demonstrations of this is the double-slit experiment. When particles are fired through two narrow slits without being observed, they behave like waves, creating an interference pattern on a screen behind them. But when scientists place detectors to observe which slit each particle passes through, the interference pattern disappears. The particles behave like solid objects instead. Nothing else changes. Same particles, same slits, same equipment. The only difference is observation. This forces a disturbing question. What exactly is the observer doing? Some interpretations suggest that measurement physically disturbs the particle. Others argue that information itself plays a role. And then there are interpretations that go even further, suggesting that consciousness may be involved, though this remains highly controversial. What cannot be dismissed is the fact that the outcome depends on whether observation occurs. This is not a poetic statement, it is mathematical. Before measurement, quantum systems are described by a wave function, which contains all possible outcomes. After measurement, only one outcome remains. The transition from possibility to fact happens at the moment of observation. Physics can describe the probabilities with extreme precision, but it cannot fully explain why a specific outcome appears when it does. This gap between calculation and explanation is where the paradox becomes uncomfortable, because if observation is not just revealing reality, but actively participating in its formation, then the observer is no longer outside the system. The observer is part of the mechanism. This undermines the traditional scientific stance of objectivity, where the scientist stands apart from what is being studied. Even Albert Einstein struggled with this implication. He famously resisted the idea that reality could depend on observation, insisting that the moon exists whether or not someone looks at it. Yet experiments have consistently confirmed quantum predictions, not classical intuition. What makes this paradox especially unsettling is that it is not limited to abstract theory. Modern technologies rely on it. Semiconductors, lasers, MRI machines, and quantum computing all depend on quantum behavior that includes observer-dependent effects. The paradox is not optional. It is embedded in the functioning of the world you interact with every day. And yet, there is a subtle trap here. Many people hear about the observer effect and immediately jump to the idea that mind creates reality in a simplistic way, that thoughts directly control matter. Quantum physics does not say that. The observer effect is not about wishful thinking or belief alone. It is about interaction, measurement, and information. The danger lies in misunderstanding it as mystical control rather than participatory influence. This is where even scientists must be careful. The observer effect does not mean that you can choose outcomes at will. It means that outcomes are not fully defined until observation occurs. It points to a universe that is less like a machine and more like a process, less like a static structure and more like a negotiation between possibility and actuality. What makes this terrifying to many scientists is the implication that the universe does not have a single, observer-independent story unfolding in the background. Instead, reality seems to crystallize through acts of observation, again and again at every level. And this leads to a deeper unease. If observation plays such a role at the quantum level, what does that suggest about larger systems, about time, about causality, about the way experience itself is structured? These questions push beyond particles and laboratories and into the nature of perception itself. Because once you accept that observation changes what is observed, you can no longer assume that time, events, or even your own experiences are as fixed as they appear. The act of noticing may not be neutral. It may be shaping the very flow of what unfolds next. And that brings us to an even more disorienting idea, one that challenges not particles, but time itself. Time feels like the most reliable element of reality. It moves forward. It never stops. It treats everyone the same. Or at least, that is how it appears from everyday experience. You wake up, the clock advances, the day unfolds in a predictable sequence. Because time seems so stable, we rarely question whether it might be influenced by something as subtle as observation. Physics tells a different story. When scientists began to examine time with the same rigor they applied to space and matter, the certainty collapsed. In Einstein's theory of relativity, time is not absolute. It stretches and contracts depending on speed and gravity. Clocks on satellites tick at a different rate than clocks on Earth. Astronauts age more slowly than people on the ground by tiny but measurable amounts. Time, it turns out, is not a universal river flowing at the same pace everywhere, but relativity only opens the door. The deeper paradox emerges when observation enters the picture. In quantum mechanics, time is not treated as a fixed background where events happen. Instead, it behaves more like a parameter tied to measurement. Certain experiments suggest that quantum systems do not evolve in a definite way until they are observed. Between measurements, their behavior cannot be described as a clear sequence of events. It exists as a set of possibilities, not a timeline. This raises a disturbing question. If observation helps determine what happens, could it also influence when it happens? Consider experiments involving quantum decay. Radioactive particles decay at random times. No equation can predict the exact moment a single particle will decay, only the probability that it will decay within a given time frame. Yet the moment of decay becomes definite only when it is detected. Until then, the system exists in a strange limbo, where the event has not fully occurred in any classical sense. Some physicists argue that time itself, at the quantum level, emerges through observation. That what we experience as a flowing timeline may be a result of repeated measurements stitching reality into a coherent sequence. Without observation, there may be no clear before and after at all. This idea is deeply unsettling because it undermines one of our most basic intuitions, that time exists independently of us. Even more unsettling is how closely this aligns with human experience. Psychologically, time is highly elastic. Moments of fear seem to stretch endlessly, while hours of joy disappear in what feels like minutes. Neuroscience shows that the brain does not measure time with a single internal clock. Instead, it reconstructs time based on attention, memory, and sensory change. When you pay close attention, time appears to slow down. When attention fades, time accelerates. This is not just a metaphor. Brain imaging reveals that different neural circuits become active, depending on how closely we observe our surroundings. The more detailed the observation, the denser the memory encoding. And memory density is one of the main factors that determines how long a period feels in retrospect. In other words, observation does not just shape what you perceive, it shapes how long that perception seems to last. Now place this insight back into physics, and the paradox deepens. If observation influences the definition of events at the quantum level, and if human perception actively constructs temporal experience, then time may not be a fixed container holding reality. It may be a relational phenomenon arising from interaction between observer and observed. Some modern theories go even further, proposing that time is not fundamental at all. According to these views, time emerges from more basic processes, such as correlations between systems. What we call time passing may simply be the way an observing system organizes change. This reframes the question entirely. Instead of asking whether time flows, we must ask whether time is being generated through observation, whether each act of measurement, attention, or awareness contributes to the structure we interpret as temporal order. This does not mean that you can stop time by staring at a clock or rewind it by refusing to look. The paradox is subtler than that. It suggests that without observation, there may be no meaningful way to define when something happens. Events do not line up neatly in a timeline until they are registered, recorded, or experienced, and this leads to a quiet but profound discomfort. If time depends on observation, then what happens when there is no observer? Does the universe exist in a timeless state, waiting for measurement, or does it generate its own form of observation, independent of human awareness? These questions push science to the edge of what it can test experimentally. They also reveal a hidden assumption we rarely examine, that reality is always being watched, which brings us to a more unsettling paradox still. What if observation is not guaranteed? What if existence itself does not require a witness in the way we assume? Or what if the idea of a witness must be radically redefined? Because once time itself becomes questionable, the role of the observer can no longer be taken for granted. And that opens the door to a paradox that challenges the very idea of existence continuing when no one is looking. There is a question so simple that it sounds almost childish, yet it unsettles some of the deepest foundations of science and philosophy. What happens when nothing is observing the universe? Not when no human is watching a specific event, but when observation itself is absent. Does reality continue exactly as it was, or does something more ambiguous occur? At first glance, the answer seems obvious. Of course, the universe continues. Stars explode, galaxies collide, particles interact, all without anyone there to witness it. This assumption feels necessary for sanity. But when examined through the lens of modern physics, it becomes far less secure than we would like. In quantum mechanics, systems behave differently depending on whether they are observed. Before measurement, a system exists in a superposition of possibilities. After measurement, it collapses into a definite state. This leads to an uncomfortable implication. Observation seems to play a role in determining what is real. But if that is true, then what qualifies as an observer? Is it a human being, a conscious mind, a measuring device? Or is observation something more fundamental, embedded in the structure of the universe itself? This question lies at the heart of the universal observer paradox. If reality requires observation to become definite, then a universe without observers should remain in a perpetual state of uncertainty. And yet, the universe clearly existed long before humans, before life, before planets. Cosmic background radiation, fossilized in space, tells us that the universe had structure and temperature just moments after the Big Bang. How could that be, if no one was there to observe it. One response is to say that measurement does not require consciousness. A particle interacting with another particle counts as observation. Information is exchanged and reality takes shape. In this view, the universe is constantly observing itself. Every interaction acts as a form of measurement, collapsing possibilities into outcomes. But this solution creates another problem. If every interaction is an observation, then the concept of an observer loses its meaning. Observation becomes synonymous with interaction. The paradox dissolves, but at a cost. The original mystery is avoided rather than resolved. We are left with equations that work, but no clear understanding of what observation actually is. Other interpretations take a more radical approach. Some suggest that all possible outcomes occur, branching into separate realities. In this framework, observation does not collapse anything. It merely places the observer in one branch of a much larger multiverse. Reality continues whether you look or not, but you only experience a tiny slice of it. This idea removes the need for a universal observer, but introduces a different kind of unease. If every possibility exists, then the universe becomes unimaginably vast and fundamentally untestable. Observation loses its creative role, but meaning becomes diffuse, spread across countless unseen worlds. There is also a more philosophical tension hidden in this paradox. Human experience is built on the assumption that things exist even when we are not paying attention. You leave a room, and you trust that it will still be there when you return. Memory, planning, and identity all depend on this assumption. Yet at the deepest level of physical theory, this certainty begins to erode. Some thinkers propose that existence itself is relational. Things do not exist in isolation, but only in relation to other things. In this view, an object without any relationship, without any form of interaction or observation, has no defined properties. Existence is not a static state, but an ongoing process of being registered by something else. This shifts the paradox in a subtle way. The question is no longer whether reality exists without observers, but whether existence has any meaning without relation. A universe completely devoid of observers, interactions, or measurements might not be nothing, but it would be indistinguishable from nothing in any describable sense. And this leads to an even deeper discomfort. If observation is fundamental, then the universe may require some form of witnessing to be what it is. Not necessarily human witnessing, but some principle of registration, awareness, or interaction that allows states to become defined. This idea borders on metaphysics, yet it arises directly from attempts to interpret physical experiments. Scientists are cautious here for good reason. The line between rigorous explanation and speculation is thin, but the paradox persists because no interpretation fully removes the mystery. Each solution explains part of the problem while leaving another part exposed. What makes this paradox especially unsettling is that it mirrors something deeply personal. Your own sense of existence is tied to awareness. When you are unconscious, time disappears, experience vanishes. From your perspective, nothing happens. Only when awareness returns does the world reassemble itself into continuity. This subjective gap hints at a connection between observation and existence that we rarely examine directly. The universal observer paradox forces us to ask whether reality itself might have a similar dependence, not on human minds specifically, but on some principle of observation that allows events to become real rather than merely possible. And once that door is opened, another paradox waits on the other side. One that does not ask whether something exists when unobserved, but asks how a single thing can exist in more than one form at the same time, depending entirely on how it is observed. Imagine discovering that something you thought you understood can never be pinned down to a single identity. It behaves one way when you look at it from a distance, and another way when you examine it closely. Not because it is changing its nature, but because your method of observation determines what aspect of it appears. This is not psychology. This is one of the core facts of modern physics, known as wave-particle duality. Light was the first clue. For centuries, scientists argued about what light truly was. Some experiments showed it behaving like a wave, spreading out, interfering with itself, creating patterns of light and dark. Other experiments showed it behaving like a stream of particles, delivering energy in discrete packets, striking detectors one point at a time. For a long time, the debate was framed as a mistake waiting to be corrected. Light had to be one thing or the other. Quantum physics revealed the more disturbing truth. Light is both. Photons do not secretly switch between being waves and particles. Instead, they exist in a state that cannot be fully described by either concept alone. The description you get depends entirely on how you observe them. If you design an experiment to measure wave-like properties, you will find a wave. If you design an experiment to measure particle-like properties, you will find particles. What you cannot do is see both at the same time. This is where the paradox becomes deeply unsettling. The properties you observe are not simply uncovered, they are selected. The experimental setup, the questions you ask of the system, determine which version of reality becomes visible. Before observation, the system does not commit to either identity in the way classical objects do. The double-slit experiment makes this painfully clear. When photons pass through two slits without which path information being measured, they form an interference pattern characteristic of waves. Each photon seems to interfere with itself, as if it travels through both slits simultaneously. But when detectors are added to determine which slit the photon passes through, the interference pattern vanishes. The photons behave like particles, choosing one path or the other. Nothing else changes. Not the photons, not the slits. Only the availability of information. This leads to a disturbing conclusion. Reality at the quantum level is sensitive to what can be known. The mere possibility of gaining information about a system can change its behavior. It is not that the photon knows it is being watched, but that the structure of observation reshapes the range of outcomes. Some experiments push this paradox even further. In delayed choice experiments, the decision about how to observe the photon is made after it has already passed through the slits, and yet the outcome still aligns with the type of measurement chosen. It is as if the photon's past behavior is influenced by a present decision about observation. Physics is careful with its language here. No one claims that the past is being rewritten in a classical sense. But the fact remains, quantum events do not settle into a single story until measurement occurs. The timeline we imagine, where events happen first and are observed later, does not cleanly apply. This shakes a fundamental assumption we rarely question, that objects have definite properties whether or not we look. Wave-particle duality suggests that properties are not simply possessed, they are revealed in context. The question, what is it, cannot be answered without also asking, how are you observing it? Identity at this level is relational. This is deeply counterintuitive because macroscopic objects do not behave this way. A baseball does not become a cloud of possibilities depending on how you look at it. The reason we do not see wave-particle duality in everyday life is not because it disappears, but because interactions with the environment constantly force macroscopic objects into definite states. Observation, in a broad sense, is happening all the time, but the underlying principle remains. At the foundation of reality, the universe does not present itself as a set of fixed entities with intrinsic properties. It presents itself as a range of potential behaviors, constrained and shaped by observation. What exists is not just what is out there, but what emerges through interaction. This is where the paradox becomes existential. If the nature of something depends on how it is observed, then the role of the observer is far more active than classical thinking allows. You are not simply discovering what is already there. You are participating in a process that determines which aspect of reality becomes actual. This does not mean that consciousness magically creates particles. It means that the framework of observation, the way questions are posed to reality, matters at a fundamental level. The universe responds not with a single answer, but with the answer that fits the measurement, and this raises an uncomfortable parallel with human perception. In daily life, people often believe they are neutral witnesses to events, that they see things as they are. But perception is always shaped by attention, expectation, and context. What you focus on becomes more real to you. What you ignore fades into the background. While this is not quantum physics, the structural similarity is difficult to ignore. Wave-particle duality forces us to confront the possibility that reality itself may not have a single, observer-independent face. Instead, it may present different aspects depending on how it is engaged. And once you accept that observation selects outcomes and identities, another question naturally arises. If observation is so powerful, what happens when it is guided by intention, belief, or expectation? At what point does looking stop being neutral and start quietly shaping what appears to be real? One of the most comforting ideas we carry is also one of the most misleading: the belief that we are simply watching the universe unfold. That reality happens out there, fully formed, while we stand at a safe distance, recording events like impartial witnesses. This assumption feels natural because it keeps responsibility low and certainty high. If we are only spectators, then the world is not our concern in any deep way. It just is. But this belief does not survive serious examination. Modern physics has already shown that observation alters outcomes at the most fundamental levels. Neuroscience shows that perception actively constructs experience rather than passively receiving it. Yet, despite this, the spectator mindset persists, quietly shaping how people interpret both science and their own lives. The mistake begins with a misunderstanding of objectivity. Objectivity is often imagined as detachment, as if the more distant you are from what you observe, the more accurate your view becomes. In practice, no observation is ever truly detached. Instruments must be designed, questions must be framed, data must be interpreted. Every step involves choices. Those choices define what can be seen and what remains invisible. In physics, this is obvious. The kind of detector you build determines which properties of a particle become measurable. You cannot measure everything at once. You must choose. And that choice shapes the outcome. The observer is embedded in the process, not hovering above it. In human perception, the same principle operates, though it is easier to ignore. Your senses do not deliver a complete picture of reality. They filter, prioritize, and interpret. Attention acts like a spotlight, illuminating certain details while leaving others in darkness. What you notice becomes your reality, while what you overlook effectively does not exist for you. This is not a flaw. It is how perception works, but it means you are never just watching. You are actively selecting. The spectator illusion becomes dangerous when it leads people to believe that their inner state has no influence on what unfolds. That thoughts, expectations, and attention are irrelevant to outcomes. While this is not the same as claiming that the mind controls the universe, it ignores a subtler truth. How you engage with reality affects which aspects of it you encounter. Consider how expectations shape interpretation. Two people can witness the same event and walk away with entirely different conclusions. The event did not change, but the reality they experienced did. Over time, these differences compound, shaping decisions, relationships, and life trajectories. The spectator mindset hides this influence by pretending that perception is neutral. Science itself had to confront this illusion. Early physicists believed that better instruments would eventually reveal the universe as it truly is, independent of observers. Instead, better instruments revealed deeper layers of observer dependence. The more precisely scientists measured reality, the more they discovered that measurement choices mattered. This does not weaken science. It strengthens it by making assumptions explicit. The real problem arises when people apply the spectator model to their own lives, when they believe they are merely reacting to circumstances rather than participating in their formation. This belief subtly discourages responsibility and curiosity. If you are only watching, then there is nothing to examine about how you look. Yet attention is not passive. Where you place it alters neural pathways, emotional responses, and patterns of behavior. Neuroscience shows that repeated focus strengthens certain circuits in the brain. Over time, this changes how you perceive the world and how you act within it. Observation becomes training. This is where the mistake deepens. People often assume that influence requires effort or intention. That unless they are actively trying to change something, they are not affecting it. But influence happens continuously, through habitual ways of seeing, through assumptions left unexamined, through stories repeated until they feel like facts. The universe you experience is not just shaped by external events, but by the lens through which those events are processed. This does not mean reality is imaginary. It means that reality, as lived, is co-created through interaction. The idea of being a mere spectator collapses because there is no clear boundary between observer and observed. You are inside the system you are trying to understand, and this is precisely what makes the next realization uncomfortable. If you are not just watching, then the way you watch matters. If observation participates in shaping outcomes, then intention, expectation, and focus become variables in the equation, not in a magical sense, but in a practical one. This opens the door to a more subtle danger. Once people realize they are not spectators, they often swing to the opposite extreme, believing they can control reality simply by focusing on it. This replaces passivity with illusion. The truth lies in between. Influence is real, but it is constrained. Observation shapes possibilities, not guarantees. The mistake is not underestimating your role, but misunderstanding it. And that misunderstanding becomes especially risky when observation is guided by strong expectations, because when you look for something with certainty, you may not be discovering reality at all. You may be narrowing it without realizing what you have excluded. Which brings us to a more delicate paradox. What happens when intentional looking, driven by belief or desire, quietly distorts what you think you are seeing? Once the idea takes hold that observation is not neutral, a subtle shift occurs. People begin to wonder whether looking with intention can shape outcomes. This is where curiosity can quietly turn into distortion. Because while observation does influence experience, intentional looking introduces expectations, and expectations are not passive lenses. They are active filters. In science, this danger is well known. Researchers design experiments knowing that expectations can contaminate results. This is why blind and double-blind studies exist. If a scientist knows what outcome they hope to see, they may unconsciously influence the measurement, the interpretation, or even the way data is collected. The phenomenon is called observer bias, and it is not a failure of integrity. It is a feature of human cognition. The mind is wired to detect patterns, confirm beliefs, and resolve uncertainty quickly. When you expect something to happen, your attention becomes selective. You notice confirming evidence more easily and dismiss contradictions without realizing it. Over time, expectation hardens into certainty, and certainty feels like truth. This is where intentional looking becomes dangerous. At the quantum level, measurement choices determine which properties become visible. At the human level, expectation determines which aspects of experience stand out. The parallel is structural, not mystical. In both cases, the observer shapes the informational boundary of what can be known. Consider how this operates in everyday life. If you expect people to be untrustworthy, you will notice every small sign that confirms it. Hesitations, ambiguities, mistakes become evidence. Signals of goodwill fade into the background. Your experience of reality becomes narrower, not because the world has changed, but because your observation has. The expectation does not create untrustworthy people, but it creates a world in which trust rarely appears. The danger lies in mistaking this filtered experience for objective reality. In physics, no serious scientist would claim that observation gives unlimited control. Measurement affects outcomes, but within strict constraints. Probabilities shift. They do not collapse into fantasy. Yet when people hear that observation matters, they often translate it into a simplistic belief that focus alone creates results. This misunderstanding replaces passivity with illusion. Intentional looking does not bend reality to your will. It bends your access to reality. This distinction is critical. Expectation changes what you sample from the world. It alters where attention lands, how long it stays, and what gets remembered. Neuroscience shows that perception and memory are deeply intertwined. The brain does not record a neutral stream of data. It builds a narrative that fits existing models. When expectations are strong, those models dominate. This can feel empowering at first. People believe they are finally taking control. But control built on distortion is fragile. In scientific practice, expectations are constantly challenged. Data must survive scrutiny, replication, and attempts to disprove it. In personal observation, expectations often go unchallenged. There is no peer review for belief, no control group for perception. This makes intentional looking especially risky outside the laboratory. The danger is not that expectations influence experience. That is unavoidable. The danger is forgetting that they do. Once forgotten, intentional looking turns into self-confirmation. Every observation becomes evidence. Every outcome reinforces the original belief. The loop tightens and alternative interpretations disappear. Reality feels solid, but it has quietly narrowed. This narrowing has consequences. It shapes decisions, relationships, and emotional responses. It determines what feels possible and what feels closed. Over time, life begins to reflect the limits of observation rather than the full range of potential experiences. In this sense, intentional looking alters reality, not by changing the universe, but by changing the field of available outcomes you are able to perceive and respond to. Science warns us about this through the concept of falsifiability. A claim that cannot be tested against opposing evidence is not reliable. Yet many personal beliefs operate exactly this way. They absorb confirmation and deflect contradiction. Intentional looking becomes a shield rather than a tool. This is why the idea of observation as power must be handled carefully. Power without calibration leads to error. Awareness without humility leads to distortion. The observer effect does not grant immunity from self-deception. In fact, it makes self-deception easier if not examined. Some of the most disciplined scientists express discomfort with observer-dependent phenomena, not because they fear mystery, but because they recognize the limits of human perception. They know how easily observation slips into projection, how quickly interpretation becomes belief. This brings us to an important tension. If observation influences reality and expectation influences observation, then the observer must constantly question themselves. Not to eliminate influence, which is impossible, but to recognize it. To hold uncertainty open rather than closing it too quickly. And this is precisely what frightens many scientists. Because once you accept that observation plays a role, you must also accept that the observer is never fully transparent to themselves. There is always bias, always framing, always a hidden hand shaping what appears. The question then becomes not how to control reality through observation, but how to avoid being lost in it, how to observe without becoming trapped inside your own expectations. And that leads directly to the quiet fear faced by those who study these phenomena most closely, the fear of losing the boundary between observer and observed altogether. For most people, science appears calm and confident. Equations are written, experiments are repeated, results are published. From the outside, it looks like a steady march toward clarity. But beneath that surface lies a quieter tension, one that few talk about openly. The fear is not that experiments will fail, but that they will succeed in revealing something too unsettling about the role of the observer. Because once observation is no longer neutral, the scientist is no longer safely outside the system. Many physicists enter their field believing that with enough rigor, the universe can be described from a detached point of view. Yet the deeper they go, especially into quantum mechanics, the more that detachment erodes. Measurement choices matter. Framing matters. Even deciding what counts as a result becomes part of the phenomenon. This creates a subtle psychological strain. Scientists are trained to minimize personal influence, not eliminate it. They rely on protocols, statistical methods, and peer review to keep subjective bias in check. These tools are not just technical safeguards, they are psychological anchors. They protect the observer from drifting too close to what is being observed. Without these anchors, the line between observer and phenomenon becomes dangerously thin. History offers glimpses of this discomfort. Early quantum pioneers openly struggled with the implications of their own theories. Some argued fiercely against observer-dependent interpretations, not because the math was wrong, but because the philosophical cost felt too high. Accepting that observation plays a role in shaping reality felt like stepping onto unstable ground. If the observer is part of the process, where does science end and introspection begin? This question is rarely asked directly, yet it shapes how scientific frameworks are built. Many interpretations of quantum mechanics exist largely because no single explanation feels psychologically safe enough to accept completely. Some minimize the role of the observer, others multiply realities to preserve objectivity. Still others remain agnostic, focusing only on predictions and refusing to speculate about meaning. This refusal is not cowardice, it is discipline. By limiting claims to what can be tested, scientists protect themselves from being pulled into endless self-reference. Observation can loop back on itself. The observer observes the system, then observes their own observation, then questions the framework of observation itself. Without boundaries, this becomes paralyzing. The fear of losing oneself in observation is not about madness or mysticism. It is about the collapse of stable reference points. Science depends on shared standards, reproducibility, and external checks. If reality becomes too dependent on individual observation, those standards begin to wobble. This is why scientific training emphasizes skepticism, not certainty. Skepticism acts as a stabilizer. It reminds the observer that any conclusion is provisional. That interpretation is not identity. That personal meaning must not override empirical restraint. These practices allow scientists to work at the edge of the unknown without falling into it. Yet even with these safeguards, the discomfort remains. Some researchers quietly acknowledge that the deeper they go, the harder it becomes to maintain a clean separation between what they study and how they study it. The universe begins to look less like an object and more like a relationship. Less like a thing and more like a process that includes the observer as a variable. This realization can be destabilizing. It challenges the idea of a fixed self as well. If observation is participatory, then the observer is also being shaped by the act of observing. Knowledge is not one way. Each experiment leaves a trace, not just in data, but in perspective. Scientists cope with this by grounding themselves in method rather than meaning. The method becomes a kind of compass. Hypothesis, measurement, error analysis, replication. These steps create distance not from reality, but from personal projection. They allow engagement without absorption. There is a quiet humility in this approach. Science does not claim to own reality. It claims to model it approximately under specific conditions. This humility is essential when dealing with observer-dependent phenomena. It keeps the observer from becoming the center of the universe they are trying to understand. Still, the tension cannot be eliminated entirely. At conferences and in private conversations, some scientists admit to a lingering unease, a sense that observation opens a door that cannot be fully closed. That understanding reality may require acknowledging limits not just in knowledge, but in the observer themselves. This is where science brushes against something older than equations, not belief, but awareness. To observe without losing oneself requires a delicate balance. Engagement without identification, curiosity without attachment, precision without certainty. Scientists develop this balance through practice, often without naming it. It is embedded in the culture of careful language, cautious claims, and respect for uncertainty. And yet outside the laboratory, these protections are rarely present, which raises an important question. If trained scientists struggle with the psychological weight of observation, what happens when observation is approached not through instruments, but through lived experience, through attention, meaning, and inner awareness rather than detectors and data. Because beyond physics, there is another domain where observation is central, but the rules are far less defined. A domain where the observer does not stand behind glass, but is fully immersed in what is being observed. When spirituality speaks about observation, it does not mean measurement, data, or instruments. It speaks about awareness, about the simple, unsettling fact of being conscious at all. This is where the paradox of reality takes on a different tone, not because science disappears, but because the observer is no longer protected by distance. In spiritual traditions across cultures, observation is not something you do to the world. It is something that happens within it. Awareness is not positioned outside reality, looking in. It is embedded, participating, inseparable from what is perceived. This perspective feels intuitive to some and deeply uncomfortable to others, especially those trained to value detachment. Yet the tension mirrors what physics has already uncovered. In quantum mechanics, the observer cannot be fully removed from the phenomenon. In spirituality, the observer cannot be separated from existence itself. Both challenge the idea of an independent, self-contained universe unfolding on its own. Both suggest that reality is relational, not isolated. Spiritual observation begins with attention. When attention is scattered, reality feels fragmented. Thoughts pull in different directions, sensations blur together, and experience becomes shallow. When attention stabilizes, something changes. Not externally, but in how the world appears. Details sharpen. Time feels different. Meaning emerges where none was noticed before. This is not imagination. It is a shift in how information is processed. Neuroscience supports this in quiet ways. Focused attention alters brain activity, synchronizing regions that normally operate separately. The result is a sense of coherence. Spiritual traditions describe this long before scanners existed, not as a theory, but as an experience. When attention is unified, reality feels whole. This is where the paradox deepens. In spirituality, observation is not meant to control outcomes or impose beliefs. It is meant to reveal connection. The observer does not shape reality through force, but through presence. The act of noticing becomes an act of participation, a way of aligning with what is already unfolding. From this perspective, the universe is not something you stand apart from. It is something you belong to. This idea can sound abstract until it is felt directly. In moments of deep attention, the boundary between observer and observed softens. You are still aware, but the sense of separation diminishes. The world feels less like an object and more like a field of relationships, including you. Spiritual traditions describe this in many ways. Unity, interbeing, wholeness. The language differs, but the observation is consistent. When awareness is clear and unfiltered by expectation, reality reveals itself as interconnected rather than divided. This does not contradict science. It addresses a different layer. Science asks how reality behaves under measurement. Spirituality asks how reality is experienced when observation turns inward. One maps patterns, the other explores meaning. Both encounter paradox when the observer becomes unavoidable. The danger here mirrors the danger in physics. Just as intentional looking can distort scientific results, spiritual observation can be hijacked by belief. When observation becomes a tool to confirm ideas about enlightenment, purpose, or cosmic significance, it loses its grounding. Awareness collapses into narrative. Connection turns into projection. Authentic spiritual observation is quiet. It does not rush to conclusions. It notices sensations, thoughts, and emotions without claiming ownership. This restraint is what keeps the observer from becoming lost in interpretation. In this way, spirituality faces the same challenge scientists do: how to observe without distorting, how to participate without dominating, how to remain present without assuming control. Where spirituality diverges is in its acceptance of subjectivity. Instead of trying to eliminate the observer, it refines the observer. Attention is trained, not to escape influence, but to become aware of it. Bias is not denied, it is seen. Expectation is not suppressed, it is noticed as it arises. This creates a different relationship with reality. Rather than asking, "What is the universe doing?" the question becomes, "How am I meeting what is happening?" Reality is no longer a puzzle to be solved, but a process to be engaged with honestly. From this perspective, observation becomes a bridge between inner and outer, between self and world, between moment and meaning. The observer does not stand at the center, nor does the observer disappear. Instead, awareness becomes a point of contact, where reality expresses itself through experience. This is why spirituality often speaks of responsibility rather than control. If observation connects you to the whole, then how you observe matters. Not because it alters particles or timelines, but because it shapes how you live within the world you are part of. Attention becomes an ethical act. Presence becomes participation. This idea can feel unsettling because it removes the safety of distance. You are not watching the universe from the outside. You are woven into it, moment by moment, through awareness. And once this is seen, even briefly, the earlier paradoxes take on a new light. The fear of observation, the instability of time, the question of existence without witnesses, all of them begin to point toward the same quiet insight. Reality is not something happening elsewhere. It is something unfolding in relationship with observation itself. What these paradoxes quietly reveal is not a universe that is chaotic or fragile, but one that is deeply relational. Observation is not an afterthought added to reality. It is woven into how reality takes shape, how time feels, how meaning emerges. You are not standing outside the universe, watching it like a distant scene. You are involved in it through attention, perception, and awareness, whether you realize it or not. This does not mean you control everything. It means you participate, and participation carries responsibility, humility, and curiosity. The way you look matters, not because it grants power over the universe, but because it shapes how the universe meets you. If this exploration resonated with you, write the phrase "I was paying attention" in the comments so I know you stayed until the end. And if you want to go deeper, watch one of the videos appearing on the screen now. If this content spoke to you, there is much more waiting there.